In this video we're going to implement the database connection class. We're already in Atom, so I'm just going to close down this response file because we're going to be creating a new file for the database class. So this new file is a controller because it'll be controlling how we connect to the database. So on the controller folder, if we right click, new file, and we'll just call it db.php for database. Start the PHP file with a PHP tag, and it's a database class. So if we start off with class db, just create some space here. Okay, the first thing we're going to do is create some instance variables, private, and these are static variables. And what this means is that you don't have to initiate the database class to use these variables. It's just a good way to sort of structure the file. So the first one is write db connection, and the next one is read db connection. Spell. So you're probably asking yourself, why is why is there a write and why is there a read connection? To give you a bit of background, it's just so it becomes scalable or easier to scale in the future. So if you use MySQL or a similar database, once you get a lot of users on your system, one database server can't usually handle the load for all the connections. The model usually followed by big businesses is that there is a lot of read database servers, so database servers that's specifically used for reading data, and then only one sort of write database or master database as it's called. And what happens in that model, the write database pushes out any updates to the read databases, or the slaves as it's called, and then every time you want to read data, you'll be pointed to a slave read only database. Just means that a lot of systems do a lot of reading rather than writing, so it just helps balance the servers out better. And it is a very scalable model if you research on it. So what we'll do, we'll actually build this API to be scalable from the outset. So we'll create two connections, one to our write database or master database, and then the other one to the read database cluster. So this could point to a DNS entry that contains lots of read-only databases, and it'll just sort of round robin each one every time you try and read some data. It just sort of spreads the load really. So the next thing we need to do is create the functions to connect, and these will be static functions. Like I say, that just means you don't have to instantiate the database object. You can just call the class functions or the class variables. So this one is public static function connect. Right, db. Don't pass any arguments in. Okay. The first thing we need to do, this is kind of what's known as a singleton. Once you've already instantiated a connection, you don't want to keep creating connections, you just want to reuse the connection that's already created. So what we'll first do is if, and because it's a static, we're talking about the class and not an instance of this class. So we use the word self, and then it's write db connection, and we're checking to see if it's null. So if it hasn't been initiated, then this if statement will perform the initiation. Otherwise, it would just sort of return the already created connection. So if, and then we need to do so self, and then it's write db connection, and we need to create a new. We'll be using PDO in this course. PDO is very good because it's a little abstract. So because we're using MySQL on this course, you don't necessarily have to use MySQL. You could point it to Microsoft SQL Server or something like that. And instead of going through all of your code and changing all of the different queries and stuff to incorporate the new drivers, the PDO will allow you just to quickly swap out database connections. There is some sort of exceptions to that. The way that you write the SQL and stuff like that might be a flavor of MySQL rather than MS SQL. But generally, it's a good practice to use using PDO. So new, PDO, and we create the connection string. So it's MySQL, and then we define the host, which ours is on our own server. So this is localhost, and then we specify the database name, and ours was taskdb, and then we set the character set. Remember from our previous video, we are using UTF-8 exclusively in this course as well. UTF-8, no need to put a dash on that one. So that's the connection. Next, what we need to do is pass in some credentials like username and password. So ours are just the standard MAMP ones. Obviously, this if this went into production, you wouldn't use these same passwords and usernames. So first one's a username, root. The last one is the password, and that's also root. Okay, now that we've done that, we'll have to set some attributes on this new connection, and I'll explain these as we go through. So self write db connection. Oops, I've spelled connection wrong there. Equals, no, sorry, it's not that. Set attribute, no open brackets, and now what we'll do, we'll pass in some constants, which is PDO, ATTR, ERR, mode, and PDO, ERR, mode underscore exception, and I'll explain these in a second. We'll just get them added in. So write db connection set attribute, and this is PDO, keep doing PDF for some reason, PDO ATTR emulate pre pairs, and that is false. I'll just save that. So what this does is create your database connection. We'll pass in the host, which is localhost. Oops, spell mistake there. Localhost. Pass in the database name. That's called taskdb in our case. Pass in the char set. Whoops, I forgot to put char set equals. And then we'll pass in the username and the password. Then what we'll do is we'll set some attributes on the connection. We'll set the error mode for the connection to use exceptions. Now exceptions is good because you can catch exceptions, you can deal with them, you can roll back certain things if something's not right. Exceptions is a good way to error handle in PHP. You can read up a bit more on exceptions, it's sort of out of the scope of this course. But we're using the exceptions error mode for the database connections. The next attribute is emulate prepared statements. Now, not every database system can handle prepared statements, so it tries to emulate them. Prepared statements allows you to sort of create your SQL code and then put in placeholders. So then you can just assign the data to that rather than hard coding it into the SQL statement itself. And we'll show you that further on down the course when we're actually creating some queries for the database. But because MySQL does actually allow you to use prepared statements, it does have it natively, we set this to false. We don't want to emulate because actually MySQL does handle prepared statements. So you can see there that we've got the connect write database for that, and we've done the check to make sure it's not null. If it is null, we'll create a new connection. Once we've got the connection, then we just return it. So return, return self, and then it's write db, keep spelling it wrong, connection. Okay, so we just return it. The read database is exactly the same as this. So what I'm going to do, I'm just going to copy this code just to save us a bit time. I'm just going to copy that and just underneath, just quickly put it underneath. and then we'll change write where it says write, we'll just change it to read, just on all of these. I'll just quickly go through and change these. Whoops. Save us a bit of time really. And then we'll return the read. Now in this instance, you're probably thinking, well, why are these the same? Well, because we don't have a multi-server MySQL sort of an array. We just have one SQL server because we're doing this on development. We're just using MAMP, so we've only got one. But what you would do is, where it's got localhost, you just give the DNS name of your SQL cluster, basically, your MySQL cluster. So, like I say, that would always be the master database. The write is always master. And your read ones, that would probably have a DNS name of something like MySQL slaves or something like that. And that would just round robin between all of the slave databases. That's sort of out the scope of this course. If you want to read a bit more up on sort of scaling MySQL, please do. But just to show you sort of how we're going to allow this to be scaled really simply, we'll just start off with this course with having this in. It's only a slight tweak. It's easier to do now than to change all of your code later on. Now, there is reasons why you would connect to the right database. Updates from the write database or the master database to the read slaves is asynchronous, which means that once something's updated in this, it's not immediately updated in the read database. So that can cause issues, for example, with authentication. If someone changes a password or refreshes an access token, which we'll be talking about later, if the authentication was reading from the read database, but we have just refreshed our token, but to return it, we're looking at this, it may have not had time yet to move or to be pushed from the master database to the slaves. So things like authentication, when you are updating, say, a task in our case, you would do the update and return it from the write database because it's immediately updated in this database. If you updated it in there, but then try to recall it from the read database, you might get an out-of-date task. Now, if you are just returning tasks, there's no problem with just reading from the read slaves because, you know, it is only split seconds, and it depends on the load how long it actually takes to update the slaves. But for certain things, we do want to guarantee that the value is the same as what we've updated. So we'll be using a combination of the write database connection and the read database connections. So we'll just save that. Okay, a bit like what we've done before with the response, we can test just to make sure it connects successfully, and we'll create a test file to do this. We'll be deleting this, like I say, it is just a test. So in controller, on the controller folder, just right click, new file, and we'll call this dbtest.php. And we'll start off with a PHP tag, and we'll just save that. First thing we need to do is to pull in the database PHP file, just like we did before, because that's where our code is. So because we've created this test file in the same folder as where db.php is, we can just call that file directly, otherwise just enter the path of where that file is. So db.php. And then because we are using exceptions, we'll have to try and run something. So we use the keyword try. And then we'll just set some values or variables here. Write db, and we'll just call this. And we'll try and now call the functions that were created in the db file. So we'll try and call connect write db and connect read db. Go back to the test file, so the write db. So the way that you utilize class functions and class variables is you call the name of the class. So our class was called db. So db, 2 colons, and then the function name. So connect write db. And then we'll just create another variable for read db. connect read db. Oops. So now that we try and run them, like I say, if there is an error with trying to connect, what we need to do now is handle that error. So the way that you do that is you catch an exception, you try and run something, and then any exception, you catch the exception. So we'll try and catch now. So within the catch, we can output any error. Now, I'll tell you what we'll do with this. We will return a response using our response model. So actually, this is a good test to try and pull stuff together now. So we'll have to require that in. So if we just copy that, paste that, and now we need to pull in the response.php file. But it's not in the same folder, so we'll have to go up a folder and then go into model and then the response. So how you go up a folder is ... That takes me up a folder. So I should now be in v1. So now I need to go into model. So model and then / and response.php. I'll just save that. So we're pulling in the DB file, and also we're pulling in the response model because it's a good sort of a way to pull this together, a good demonstration. If there is an error, we will reply with an error response. So we need to, a bit like what we've done in our previous test, create the response object by new response, and then we need to set the status codes. So we'll set response set HTTP status code, and we'll give this a 500 because it's a server error, because if we can't connect to the database, it's definitely a server error. And then we will set the success flag, set success, and we'll say this is false because this is where an error has occurred, and then we'll add a message, and we'll just say database connection error, and then we will send. So that sends the response back, and it's always good practice to then exit the script itself. So sometimes with exceptions, you can sort of move on if you have like there's an alternative, which is finally clause, which would run whether there has been an error or not. So it's a bit like a cleanup or something like that. I always like to call exit on here because I just want to send the response to the client and then exit the script totally, so it doesn't do anything else. So there's no harm, there can be no potential harm caused. Always exit the response. Now, if the connection was successful, we shouldn't get any sort of output. It should be just blank at the time being. Like I say, this is just a test. But if there is an error connecting, we should have an error response returned. So now that we've got that, if we fire up Postman, make sure MAM's running, of course. We'll open Postman. You can see my previous 2 requests here. We'll just create a new one, blank one here. And we'll try and call this db test file. So it's http localhost, remember, port 888/v1. And this file was in our controller folder, wasn't it? So controller / and it was called db test.php. Click send. So you can see there actually we've made a mistake here somewhere. The value that we've put in the HT access file at the beginning of the last video would allow this error to be shown. If we turned this off, we would just get a blank sort of response and we wouldn't know whether it passed or failed. So for development purposes, I'm pleased I've actually put in the HT access file the show errors or display errors parameter. So we'll go back and fix this. So you can see here that in the controller db test on line 10, we've got a bit of a syntax error. So we'll quickly go back, atom db test line 10. So here we've got try and catch, I haven't put in the catch exception. Now, exceptions have different levels. Generally, the word exception is a class. Now, everything's a subclass of exception. So things like PDO exception, which is what we're going to do. So you actually have to specify the exception that we are catching. You can catch multiple exceptions and handle them different. So, but this one is a PDO exception. And we'll just give it a name of EX. This just allows you to output any error message. If you had multiple exceptions, you could have multiple catch. So you could have this and just catch my exception and have something totally different, so you can handle the errors in different ways. But for our testing purposes, and we'll be doing that later on in the course, and I'll show you that. For my test here though, we're just catching the PDO exception. So we'll save that, go back to Postman and try and run it again. So you can see here that we've actually received an error. So there is a problem with our database connection attempt. But you can see that it's just using our standard response, which is the status code, and that mirrors the status code up there, success, and our message, no data. So now we need to figure out actually what we've done wrong. So go back to Adam. We're trying to create the database connections and there's been a problem. So if we go back to the DB and have a look in here. So by quickly looking at this, I can actually see what the problem was. We tried to open TaskDB, but actually it's called TasksDB, if you remember. So I'll save that. And then what we'll do is we'll try and call that again. So send. And you can see there we've got a blank response. But you can see that it was 200. And we get a blank response because we haven't actually created any successful response object or anything like that. It's just a test to show you that actually if there was a problem connecting to the database, and you can see there we try to open a database called TaskDB, and actually it's called TasksDB, you'll get a response or an error response back. So that was a good way just to pull the database and the response back. And actually it's a good test to show that we have a successful connection to the database. So what we'll do now is we'll delete the database test file because we don't need it anymore, so we'll just delete that. So we'll right click and delete, and we'll move to trash. Okay, so that's the database connection created. We'll just tidy up some white space here and just save that.